conduction, expansion, convection, etc. The first one involves these two things. Now, you can see these are very, very closely matched. You can barely see daylight through the space here, but the ball does fit through the ring. So if I light this heat source now, and this is just my camping stove now, to be convenient. So now if I heat the ball for 15-20 seconds or so, it's not getting red hot, but it is definitely getting warm. And I keep this cool. After a while I'll find that this no longer fits through the ring. So how can I make them fit again?
What do you think, Tor?
Wait for it to cool off. And
Yes, I could cool it. There's one more thing I could do.
yeah, you keep the other component.
So I could also heat the ring.
Yeah.
So if I heat the
The
ring,
ring.
and I need to count for this one as well, about 10 seconds-ish to give it time to heat up. So now with them both hot, the ball goes through the ring again. One of the interesting things about a ring is some people think it should get smaller when heated. But if you think of it as a strip which is getting longer, then it's obvious that it will get actually wider. So we can do it that way. We can cool them both down rapidly. We can cool one down and then it won't fit. So if we cool this down first, this is still warm, it's not going to fit. This will take a little longer since it has rather more mass. But if we get them both cooled, it should fit again. So what this is illustrating is the fact that a metal typically expands by about 1 part in 10,000, which is something that's very difficult to see without special instruments. But with a specially made piece of equipment like this, you can see that expansion. This next thing also is about expansion. This is what's called a bimetallic strip. On one side it has something mostly made of steel, which is silvery. And on the other side it has something mostly made of copper, which is this goldish color. Now, what's going to happen here is not a huge amount of expansion again, because metals don't expand that much. But the fact that these metals are different is what's going to cause the effect. So, when I put this in the flame, it's curling this way. If I turn it over, will it still curl up?
Yeah, probably.
I turn it over. What's happening is that the side that looks gold, which is the copper side, although it's not expanding very much, it's expanding at twice the rate of the other side, which has mostly iron. And so that causes it to bend. And this is a very, very useful feature used in thermostats and all kinds of things that control heat. Now if I pour water on this, you can see it goes back to its original shape.